So today we are going to discuss about this Intel 8254, the programmable timer or counter IC or a counter or timer interface. So here already we know that how to introduce some time delay with some programs, right? So when the processor need to perform some time-based activities, generally there are two methods to maintain the timings of the operations. So in one method, the processor can execute a delay subroutine. So already you know, so you'll be introducing some delay subroutine along the programs, right? So the processor can execute a delay subroutine. So in this method, the delay subroutine will load the count value in one of the registers of the processor and starts decrementing the count value. So every time or after every decrement operation, the zero flag, the status of the zero flag will be checked to verify whether the count has reached zero or not. And if the count has reached zero, and if the status flag or zero flag represents a zero, then the delay subroutines will be terminated, and now the processor desired time will be elapsed, and the processor can perform the desired time based task. So here in this method, the time is estimated in terms of processor clock periods needed to execute the delay subroutine. But in the another method, so you are having another method, the external timer. So you can have an external timer so that can maintain the timings and interrupt the processor at periodic intervals. So in the first method, the processor time is wasted just by simply decrementing the or decrementing a particular register. But in the second method, the processor time can be efficiently utilized because the processor can perform other tasks in between the timer interrupts. So one such external timer device is your 8254, and it is developed by Intel, and it has three independent counters, right? So here in 8254 you are having three independent counters that can be used for the counting function. And when the counting function or the count is over, then it will generate an output signal. That output signal can be used to interrupt with the processor to make the time based activities or to do the time based activities. So the counter value can be loaded, and the counter value can be decremented by applying a clock signal. So at the end of each counter will generate an output, so that can be used as an interrupt to the processor to initiate the time based activities. So you're having many applications of this programmable timer or counter interface. So let us see some of them. So this timer, we can use this timer can interrupt a time sharing operating system at specified intervals so that it can switch programs. So another application is it can send timing signals at periodic intervals to input output signal to analog to digital converter. The another application is it can be used as a baud rate generator. In the previous case, we have discussed about 8251A serial interface, serial communication interface. So there we can use the timer as a clock divider to divide the processor clock to the desired frequency. And also we can use the timer to measure the time between external events, and it can be used as an external event counter to count repetitive external operations and inform the count value to the processor. And the timer can be used to initiate an activity through the interrupt after a programmed number of external events have occurred. So of course, as in the previous cases, here also this 8254 is available in 24-pin IC package, 24-pin dual inline package, and it requires a 5-volt supply. So here this 8254, it has three independent 16-bit counters. So these three counters are independent and which can be programmed to work in any one of the possible 6 modes. So totally there are 6 modes of operation here. We can use these three counters. So each counter has a clock input, a gate input, and a counter output. So if you want to operate a counter, the counter value has to be loaded in the counter register, and the gate signals should be tied high, and a clock signal should be applied through the clock input. These three things you have to do. So the counter counts by decrementing the count value one by one in each cycle of the clock signal, and generates an output depending upon the mode of operation. And this generated output can be used to interrupt the processor. So let us see the pin configuration or the pin diagram of this 8254. So it is available with the 24 pin dual inline package. You see pin number 1 to 8, it represents the data lines, right? So D0 to D7, it represents the data lines. So while interfacing with 8086, you will be connecting these data lines to the corresponding data lines of the microprocessor 8086, right? And the next pin is a clock signal, clock 0. It is represented as clock 0, and output pin, the next pin number 10 is the output pin. It is represented as out 0, and gate 0. So these three pins, clock 0, out 0, and gate 0, these three pins corresponds to the clock signal, output signal, and gate signal of the counter 0, the first counter. The pin number 12 is the ground pin, and 24 is the VCC. Pin number 13 represents the output pin of the second counter, and gate 1 represents its corresponding gate signal, and clock 1 represents its corresponding clock signal. And gate 2, out 2, and clock 2 are the three pins of the counter, third counter. And this WR and read and CS, these three signals, pin number 23, 22, and 21. So 23 is write signal, so it is an active low signal, and 22 it is read signal, it is also an active low signal, and 21 is chip select signal, it is also an active low signal. And these two WR and RD, so these two pins will be connected to the processor while you interface with the corresponding read and write pins of the 8086 processor. And the chip select pin will be connected, so while interfacing you will be connecting the chip select signal to the decoder circuit. And this A0 and A1, these two select the counter, which counter has to do the counting operation. So the combination of these two signals, A0 and A1, see in the right side you are having the table. So if A0 and A1 are 0 0, then the first counter will be selected, 0 1 the second counter will be selected, and 1 0 the counter 2 will be selected. If it is 1 1, the control word will be selected, or the control register will be selected to write the control word to the control register. So it has 8 data lines. Once again we will discuss it. So it has 8 data lines, and these data lines are used for communication with the processor, and the control words and count values are written into 8254 registers through the data bus buffer. And the chip select signal is used to select the chip. The address lines A0 and A1 are used to select any one of the 4 internal devices, right? So 4 internal devices means counter 0, counter 1, counter 2 are the control register. The control signals RD and WR, they are used by the processor to perform read or write operation. The processor can read the count value in the count register without stopping counter at any time, right? Here the address lines A0 and A1, these two will be connected to the corresponding address lines A1 and A2 of the 8086 processor while you do the interface. The A1 and A2 of 8086. So A1 and A2 of 8086 are connected to A0 and A1 of 8254 to provide the internal addresses. The input output addresses allotted to the internal devices of 8254 will be the input output addresses will be 101. So the different combinations of this A0, A1, A2, A3, A4, A5, A6, and A7 are the 8 data lines. The data lines here, the data lines D0 to D7, these are connected to D0 to D7 of the processor, and the read and write signal. So as we stated earlier, these read and write signals will be connected to the corresponding read and write of the processor, write signal of the processor respectively to achieve parallel data transfer. So these are the pin descriptions. So already we have discussed about it. They are read signal, write signal is there, CS chip select signal. So these three are the active low signals, and A0 and A1 address lines, and a clock. It represents the clock input to the counter, and the counter is each counter is of 16 bits, and out it represents the output line from each counter, and gate it is the it acts as a gate for the clock input line, or it can act as a start pulse. So this is a simple block diagram of your 8254. Here the main blocks are the data bus buffer through which the data lines are connected, and the read write control logic is there. So here you are having the read signal, write signal, A0, A1, the address lines, and chip select signal, right? The read write the address lines and the CS, these will be connected to the or interfaced or connected to the corresponding the to the 8086 processor for interfacing. And the next is the control word register, the three counters are there in the right side. So here you can see the counter 0, it is the three signals, clock signals, and the gate signals. The out pin is also there for each counter. It is represented as clock 0, clock 1, and clock 2. These three clock signals, and gate signals are gate 0, gate 1, and gate 2 to corresponding counters. So here you can see how these counters are selected for various functions. For write operation, the first case for write operation, write enable is active low signals, and A0 A1 value is 0 0. So if A0 A1 is 0 0, it will select the counter 0, or it will write or load the content to the counter 0. The next one is the read operation. So here in this case, the read signal is active low. Similarly, for other counters, for counter 1, counter 2, and for writing the control word to the control register, then the read signal is high, and 1, and write is active low, because you are going to um, write something to the control register. So this represents the format of control word of timer 8254. Each counter of this 8254 can be individually programmed, as we stated earlier, by writing a control word followed by a count value. So here you can see the 8 bits, the first 2 bits, the MSBs, B0 and B7 and B6. So these two will select the counter, right? The combination of these 2 bits, that is 0 0. If it is 0 0, then it will select the counter 0 0 1 means it will select counter 1 1 0 means it will select counter 2, and 1 1 is a it will select a read back command, or it's an illegal operation. And the next 2 bits RW1 and RW0. So the combination of these 2 bits, 0 0 means a counter latch command, and 0 1 means a read write LSB alone, and 1 0 means a read or write operation MSB and the MSB only, and 1 1 means a read or write operation LSB first and then the MSB. The next 3 bits M2, M1 and M0, the bit number bit 3, 2 and bit 1. So these three actually decides the mode of operations of the first particular counter. So the combination, if these three combinations, there is three bits are 0 0 0, then mode 0 will be selected. 0 0 1 means first mode 1 will be selected, and don't care 1 0 means mode 2 will be selected. Again, don't care 1 1 means mode 3 will be selected. 1 0 0 means mode 4 will be selected. 101 means mode 5 will be selected, and the LSB bit BCD, so it represents, so if it is a 1, then it represents BCD count, and if it is a 0, it represents binary count. This is the format of the control word for timer 8254. So in the control word, the bit B0, so BCD of the control word is used to select BCD or binary count, and the bits B1 to B3, M0, M1 and M2. So here are used to select the mode of operation for the counter specified by bits B6 and B7 of control word. So here in this place, you please remember that for each counter, separate control word has to be sent to the same control register addresses, right? the 8254 will identify the control word for a particular counter from bits B6 and B7 of the control word. Here the bits B4 and B5 are used for read or write command. These bits generally are programmed for reading or writing the 16-bit count value in proper order. So if the count value is read without stopping the counter, then the count value may change between reading the LSB and MSB. So to avoid this, the counter latch command can be used to latch the count value to an internal latch available at the output of each counter before the read operation, right? Or alternatively, a separate read back control word is available for latching the count value in 8254. But this feature is not available with the 8253. So here we can see the format of this read back control word in the next class, and also the mode of operation in the next class. Thank you.